Today I'm going to start the first chapter of organic chemistry, that is haloarenes and haloalkanes. Now last year you would have studied the nomenclature part in detail as well as reaction mechanism. So that part I'm not going to discuss. I'm directly going to the chapter haloalkanes and haloarenes. Now what is a haloalkane? How do you get a haloalkane? Now for hydrocarbons, we write it as RH, writing. So in a hydrocarbon, when the hydrogen atom is being replaced by a halogen atom, then we call it as what? Haloalkane. So the general formula for haloalkane is RX. R is the alkyl part and X is the halide ion, or X is the halogen atom. So haloalkanes are obtained by replacement of one hydrogen atom in a alkane by halogen atom. So that is known as haloalkane. So haloalkane is also known as alkyl halide. It's also known as alkyl halide. So how can you define a haloalkane? Haloalkane is a compound in which halogen atom is attached to a alkyl group. That is known as a haloalkane. I'm writing here C. CH3Cl. This is known as what? Methyl chloride. Or its IUPAC name is what? Chloromethane. That is, halogens are considered as what? A substituent. It's not considered as a functional group. So we are using what? Prefix. So its name is chloromethane. So this is the alkyl part and this is the halogen atom. Now CH3CH2Br. This is also haloalkane or alkyl halide. Its name is what? Ethyl bromide. Our IUPAC name will be what? Bromoethane. Now, C, next one more I'm going to write. CH3CH, CH3I. This one's common name is what? Isopropyl iodide. So, and its IUPAC name, from where will you number? Longest continuous chain, 1, 2, 3. If you go from here also, it's 1, 2, 3. So its IUPAC name is 2-iodo-propane. Okay, so this is also what? An alkyl halide. So I have written few compounds. Now you see the carbon atom to which the halogen atom is attached is in which hybridization? Now this is the carbon, here this is the carbon, and here this is the carbon. Now here how many sigma bonds are there? You just see CH3Cl. 1. So this is the structure of methyl chloride. So how many sigma bonds are there? 4 sigma bonds. 4 sigma bonds means it's which hybridization? It's in sp3 hybridization. So all this you have studied in class 11. So here this carbon is in which hybridization? sp3. Now take this carbon also. How many sigma bonds? CH3, CH, H, Br. So this is sigma, 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 sigma. So this is also in which hybridization? sp3. Now you take this one, CH3, CH, I, CH3. So this is also in which hybridization? sp3. So what do you observe? In all the cases, the carbon to which the halogen is attached is in which hybridization? sp3 hybridization. Another one more compound I'm going to write. What is this one's name? Its common name is what? Tertiary butyl chloride, and its IUPAC name, which is the longest continuous chain, 1, 2, 3. If you go from here also, it's 1, 2, 3. If you go this way also, 1, 2, 3. This way, any way you go, it's what? 1, 2, 3. So what is its name? 2-chloro, 2-methyl propane, So in this case also, what is the hybridization of the carbon? How many sigma bonds? 4 sigma bonds. So it's in which hybridization? sp3. So what do you observe in all these compounds? The carbon to which the halogen is attached in alkyl halide is in sp3 hybrid state. And you see the adjacent carbon also. It's also having what hybridization? sp3. So this is also sp3, this is also what sp3. Here also the adjacent carbons are also in which what state? sp3 hybrid state. So how will you define a haloalkane? The compounds in which the halogen atom is attached to what type of carbon atom? sp3 hybrid carbon atom. That is, haloalkanes are the compounds in which the halogen atom is attached to an sp3 hybrid carbon atom of which group? Alkyl group is known as what? Haloalkane or alkyl halide. Is it clear? What is a haloalkane? The compounds in which the halogen atom is attached to a sp3 hybrid carbon atom of the alkyl group is known as what? Haloalkane or alkyl halide. I'll just write it here. The compounds in which the halogen atom is attached to a sp3 hybrid carbon atom of alkyl group is known as haloalkane. So this is the definition of haloalkane. Or in general, I can say this way also, the compounds in which the halogen atom is attached to alkyl group. Why? Because when we specify alkyl group means the carbon atom is in which hybridization? It's in sp3. But I have just specified it, the compounds in which the halogen atom is attached to sp3 hybrid carbon atom of alkyl group is known as what? Haloalkane. Now these haloalkanes are classified into 3 categories, that is primary, secondary and tertiary. What is a primary haloalkane? I'm going to write here CH3Cl, CH3CH2Cl, then CH3CH2, CH2Cl. This is methyl chloride, ethyl chloride and propyl chloride. Now see here, this carbon is having its own existence. Now, if you take this carbon to which the halogen is attached, this carbon, in its adjacent position, how many carbon atom is there? 1. So this is known as what type of carbon? It's known as primary carbon atom. Now again you take this carbon to which the halogen is attached, in its adjacent position, how many carbon atoms are there? 1. So this is also what type of carbon? Primary. So what is a primary carbon atom? A carbon atom which has its own existence, or in its adjacent position when there is one more carbon atom, such a carbon is known as what? Primary carbon atom. So this is what type of haloalkane? This is a primary haloalkane. This also is what? Primary haloalkane, and this has its own existence, so this is also known as what? Primary haloalkane. So understood what is a primary haloalkane? The halogen atom is attached to a primary carbon atom, then we call it as what? Primary haloalkane. Then comes as secondary haloalkane. CH3, CH, CH3, Cl, CH3, CH, Cl, CH2, CH3, CH3, CH2, CH, Cl, CH2, CH3. See, in all these cases you see this carbon. This carbon is in contact with how many carbon atoms? In its adjacent position 2. So this is a secondary carbon atom. In this case also it is in contact with how many carbon atoms? 2. So this is also a secondary carbon atom. Here also it's in contact with two carbon atoms, so it's known as what? Secondary carbon atom. So you see, where is the halogen atom attached? The halogen atom is attached to a secondary carbon atom. Here also it is attached to a secondary carbon atom. Here also it is attached to a secondary carbon atom. So what will you call this as? Secondary haloalkane or secondary alkyl halide. The alkyl halides in which the halogen atom is attached to a secondary carbon atom is known as what? Secondary alkyl halide or secondary haloalkane. Then comes this tertiary haloalkane. Now see the carbon in which the halogen is attached. It is in contact with how many carbon atoms? 1, 2, 3. So it's what type of carbon? Tertiary. Here also it's in contact with how many? 1, 2, 3. So it's also what type of carbon? Tertiary. So what is a tertiary haloalkane? The haloalkanes in which the halogen atom is attached to a tertiary carbon atom is known as tertiary haloalkane. So is it clear? So haloalkanes are three types: primary, secondary and tertiary, depending upon the type of carbon atom to which the halogen atom is attached. If it is attached to a primary carbon atom, then we call it as what? Primary haloalkane. When it is attached to a secondary carbon atom, we call it as secondary haloalkane. And when it is attached to a tertiary carbon atom, we call it as tertiary haloalkane. Next is allyl halide. Listen carefully. Okay. Now you just tell me, what is the hybridization of the carbon in which the halogen is attached? Here how many sigma bonds? 1, 2 and 2 hydrogen atoms. Total how many sigma bonds? 4 sigma bonds. So it's in which hybridization? sp3. Now you see this one also. How many sigma bonds? 2 hydrogen, 2 sigma bond, and here also 2. So again it's in which hybridization? sp3. Now this compound is what? Cyclohexane. Cyclohexane, hope you remember, it's like this, no? The structure. See here. This is the structure of cyclohexane. That means each carbon is forming how many sigma bonds? 4. So it's also in which hybridization? sp3. Here also one hydrogen is being replaced by a halogen. So this is also in sp3 hybridization. You just keep this in mind. 4 sigma bonds, if a carbon atom is forming, means the hybridization is what? sp3. Then 3 sigma bonds means sp2, and 2 sigma bonds means it's what? sp hybridization. So in all these cases, the carbon to which the halogen atom is attached is in which hybridization? sp3. But can you call it as an alkyl halide? You can't call it as an alkyl halide. Why? You see the adjacent carbon atom. Is it having a sigma bond? Or is it in sp3 hybridization? It's not in sp3 hybridization. Why? Because what is the bond here? Double bond. Here also it's in double bond. See, in this case also the adjacent carbonate is having what bond? Double bond. In this case also the adjacent carbon atom is having what bond? Double bond. So you can't call it as what? An alkyl halide. Because in case of alkyl halides, the carbon halogen atom is attached to an alkyl group. Alkyl group means all the carbon will be in which hybridization? sp3 hybrid state will be the state of the carbon atom. So here you can't specify the name alkyl halide even though the carbon to which the halogen is attached is in which hybridization? It is in sp3. Why? Because the adjacent carbon atom is having what bond? Double bond. That means its hybridization is what? How many sigma bonds are there? 1, 2, and between carbon and hydrogen again it's a sigma bond, and there is 1 pi bond. So it's in which hybridization? sp2 hybridization. In this case also it's in which hybridization? sp2. In this case also it is in which hybridization? sp2. So what do you observe? The carbon to which the halogen is attached is in sp3 hybrid state, but the adjacent carbon atom is in which state? sp2. So such halides are known as allyl halides. So how will you define an allyl halide? Allyl halides are those compounds in which the halogen atom is attached to a sp3 hybrid carbon which is adjacent to a carbon-carbon double bond. Is it clear? So allyl halides are those compounds in which the halogen atom is attached to an sp3 hybrid carbon adjacent to a carbon-carbon double bond is known as allyl halide. So I'll just write it here. The halogen compounds in which the halogen atom is attached to a sp3 hybrid carbon atom adjacent to carbon-carbon double bond is known as what? Allyl halide. So what do you observe here? To write an allyl compound, minimum how many carbon atoms is required? 3 carbon atoms. Minimum there should be 3 carbon atoms. Then only you can write an allyl compound. So you know this compound's common name is allyl chloride. Because allyl means, you just keep this in mind, minimum how many carbon atoms should be there? 3 carbon atoms. Without 3 carbon atoms, we won't be able to write allyl compounds. So the common name for this one, we give it as what? Allyl chloride. What will be its IUPAC name? 1, 2, 3. It's what? 1 chloro, drop 2 ENE. So is it clear? Allyl halides, the halogen atom is bonded to an sp3 hybrid carbon adjacent to a carbon-carbon double bond. Next comes as vinyl halide. See here. Now see the state of the carbon atom to which the halogen is attached. It's in which hybridization? It's in sp2. This is a sigma bond, sigma bond, sigma bond, and then a pi bond. Here also it's in which hybridization? sp2. Here also it's in which hybridization? sp2. Got it? So you can't call it as an alkyl halide or an allyl halide. So how will you define a vinyl halide? Vinyl halides are those compounds in which the halogen atom is attached to a sp2 hybrid carbon atom of a carbon-carbon double bond. The carbon-carbon double bond is very important because you should not get confused with aromatic compounds. So what is a vinyl halide? The compounds in which the halogen atom is attached to an sp2 hybrid carbon atom bonded by means of a carbon-carbon double bond is known as a vinyl halide. So for vinyl halide, minimum how many carbon atom is required? 2 carbon atoms. Minimum 2 carbon atom is required for writing vinylic compound. So is it clear, vinyl halides? So I'll just write it. The compounds in which the halogen atom is attached to a sp2 hybrid carbon atom of carbon-carbon double bond is known as vinyl halide. Now for a vinyl halide, minimum how many carbon atom is required? 2 carbon atom. So the common name for this compound is vinyl chloride. It's known as vinyl chloride. Okay. IUPAC name will be what? 1, 2. It is what? 1 chloroethene, or just ethene, chloroethene also you can write, because wherever you put it's in which position only? First position. Next is benzylic halides. Now see, the carbon to which the halogen is attached is in which hybrid state? Again it's in sp3 only. In this case also it's in what? sp3. In this case also it is in sp3 hybrid state. Okay. So you can call it as an alkyl halide because you see you have an alkyl group also, it's in which all are in which hybridization? sp3. Then what is the difference between this halide and an alkyl halide? I am also writing here an alkyl halide. This is an alkyl halide. All these are alkyl halides. Here what do you observe? The carbon to which the halogen is attached is also in sp3. Adjacent carbons are also in which hybrid state? sp3. But what is the difference with this and this one? Here you have got what? An aromatic ring. Here also you have got what? An aromatic ring. Here also you have got what? An aromatic ring. That is, the carbon to which the halogen atom is attached is in sp3 hybrid state, and it is attached to an sp2 hybrid aromatic ring. In case of aromatic compounds, the hybridization is what? sp2. So the carbon to which the halogen is attached is in sp3 hybridization, and in its adjacent position it has got a sp2 hybrid aromatic ring. Such compounds are known as what? Denzylic halides. In this case you see all the carbon are in which hybridization? sp3 hybridization. In this case also the carbon to which the halogen is attached is in sp3. In this case also it is in which? sp3. But in its adjacent position it has got what? An aromatic ring. See, here also you have, here also you have, here also you have. And then you see these benzylic halides are also classified into 3 categories: primary, secondary and tertiary. Now this is primary because in its adjacent position there is only 1 carbon. This is what? It's secondary, and this is what? It's tertiary. So benzylic halides are also classified into 3 categories: primary, secondary and tertiary. So how will you define a benzylic halide? The halogen compounds in which the compounds in which the halogen atom is attached to a sp3 hybrid carbon atom, sp3 hybrid carbon atom, which is bonded to a aromatic ring having what hybridization? sp2 hybridization. See, aromatic rings are all in which hybridization only? sp2 hybridization only, so no need of specifying it. The compounds in which the halogen atom is attached to an sp3 hybrid carbon atom which is bonded to an aromatic ring having sp2 hybridization. Or you can write the compounds in which the halogen atom is attached to a sp3 hybrid carbon atom which has an aromatic ring at its adjacent position. So they are known as what? Benzylic halides. Okay. Next is haloarenes. Haloarenes. Okay. How will you see here? Chlorobenzene, bromobenzene, iodobenzene. Okay. See, the carbon benzene, you know the structure of benzene already, you know it. It's like this. So what is the hybridization of the carbon? It's a pi bond. It's in sp2. All the 6 carbon atoms are in which hybridization? sp2. So here also the halogen is attached to what? sp2 hybrid carbon. Here also it is an sp2 hybrid carbon. Here also it is an sp2 hybrid carbon. In vinylic halides also, what did you study? The halogen is attached to a sp2 hybrid carbon. So can you call it as a vinylic halide? We can't call it as a vinylic halide. But in this case, it is attached to an sp2 hybrid carbon of what? An aromatic compound or aromatic ring. Such compounds are known as what? Haloarenes. The compounds in which the halogen atom is attached to an sp2 hybrid carbon atom of an aromatic ring is known as what? Haloarenes. There you don't have a aromatic ring. You have what? A carbon atom in sp2 hybrid state, which is bonded by what bond? Double bond. So is it clear what is a haloarene? The compounds in which the halogen atom is attached to a sp2 hybrid carbon atom of aromatic ring. Is known as what? Haloarenes. So this is how the alkyl halides and haloarenes are classified. That is, alkyl halides, the carbon in which the halogen is attached in sp3 hybrid state. In allylic halides, it is attached to an sp3 hybrid carbon which is bonded to a carbon atom by what bond? Double bond. In vinylic halides, it is attached to halogen is attached to an sp2 hybrid carbon atom adjacent to a double bond. That means that carbon is bonded by double bond. Then in benzylic, the halogen is attached to an sp3 hybrid carbon atom and its adjacent position you have an aromatic ring. And in case of haloarenes, it is attached to the sp2 hybrid carbon atom of an aromatic ring. In your textbook, a question is there: classify the following into primary, secondary and tertiary alkyl halides, and then identify which is alkyl halide, which is allylic halide, which is benzylic halide. Just go through that. So in the next class, we'll discuss the preparation of haloalkanes and haloarenes. Just go through your the reaction mechanism of 11th. Why? Because in every chapter we come across all the reaction mechanisms. That is, what is resonance, what is inductive effect, what is electromeric effect. Just go through all that things because it will be discussed in each topic when you're coming across in this chapter. Okay, so next class we'll see.